Hello everyone. Today we will continue with our topic lines and angles. We will solve the sums of exercise 6.3. In its first question is in figure 6.39 sides QP and RQ of triangle PQR are produced to point ST respectively. Here you can see that side PQ is produced to point S and segment QR is produced to point T. Then if SPR is 135 degree and PQT is 110 degree, find angle PRQ. Let's see how we will find PRQ. In the given, it is given that TQR is a straight line. Here you can see that TQR is a straight line. So I can say that TQP plus PQR will be equal to 180 degree because they form linear pair. So here TQP plus PQR is equals to 180 degree. Now putting the values of TQP as 110 degree, here it is given that PQT or TQP one and the same thing is 110 degree. So we get PQR as 70 degree because 180 minus 110 is equals to 70 degree. Consider triangle PQR. Here the sides QP extends to S and so SPR forms an exterior angle. Here you can see that QP is extended to S, so SPR would form exterior angle, and when SPR is 135 degree, its sum would be equal to the sum of interior opposite angles. So SPR would be equal to PQR and PRQ, which is equals to 135 degree. Now putting value of PQR as 70 degree, we here found out PQR as 70 degree. We get the value of PRQ as 135 minus 70 degree. That is PRQ is equals to 65 degree. That only we had to find out that PRQ and its value is 65 degree. Next sum. In figure 6.40, x is equals to 64 degree and xyz is equals to 54 degree, and if YO and ZO are angle bisectors of XYZ and XZY respectively of triangle XYZ, find OZY and YOZ. Let's see how we will find these angles. Now we know that the sum of angles of a triangle is 180 degree. So I can write YXZ plus XYZ plus XZY is equals to 180 degree. Now we are given the measure of two angles, that is angle X and angle Y. So I can substitute those values and find the value of Z. So I get 62 degree plus 54 degree plus xzy. The value of xzy we have to find out is equals to 180 degree, which gives the value of xzy as 64 degree. Now we know that ZO or OZ is angle bisector of angle XZY. So measure angle OZY would be equal to half of XZY. Now we know the value of xzy. Substituting it here, we will get measure of angle OZY is equals to 32 degree because half of 64 is 32. Now let's find angle YOZ. We know that YO is the angle bisector of angle XYZ. So measure angle OYZ would be half of XYZ. And we know the value of XYZ is 54 degree. So measure angle OYZ would be equals to 27 degree because half of 54 is 27. Now we know that the sum of angles of a triangle is 180 degree. So and we know that measures of OYZ and OZY. And we know that the sum is 180 degree. So we can find out the measure of YOZ. Let's see how we will find it out. Now OZY plus OYZ plus YOZ is equals to 180 degree, and putting the respective values that we have found out, we will get the measure angle YOZ. So YOZ becomes 180 degree minus 32 degree. Measure of OYZ we found out as 27, sorry. Measure of OYZ as 27 degree and OZY as 32 degree. Subtracting it, we will get the measure of YOZ as 121 degree. Therefore, measure of angle YOZ is 121 degree. Next sum. In figure 6.41, if AB is parallel to DE and BAC is equals to 35 degree and CDE is equals to 53 degree, find angle DCE. Let's see how we will find it out. Here you can clearly see that AE is transversal of AB parallel to DC. So BAC and AED form alternate interior angles. So its measure would be same. And we are given that the measure of angle BAC is 35 degree. So automatically measure of angle AED would be equals to 35 degree. Now consider the triangle CDE. We know that the sum of angles of a triangle is 180 degree and we found out the angle CED and we are given the measure of CDE. So it is easy to find measure angle DCE. So we substitute the values in the equation that the sum of angles of a triangle is 180 degree. So we will get angle DCE plus angle CED plus angle CDE is equals to 180 degree. And we are given the values, we got the values of angle D and angle E. Substituting it, we will get DCE plus CED is 35 degree plus 53 degree is equals to 180 degree, which gives the value of DC as 92 degree. That only we had to find out. Therefore, measure angle DCE is 92 degree. Next sum. In figure 6.42, if PQ and RS intersect at point T such that angle PRT is 40 degree, RPT is 95 degree and TSQ is 75 degree, find measure angle SQT. Let's see how we will find it. Consider triangle PRT. Now we know that sum of the angles of a triangle is 180 degree. So measure angle PRT plus RPT plus PTR would be equals to 180 degree. And we know the measure of angles, angle P and angle R. Substituting those values, we will get the measure of angle PTR as 45 degree. Now in the figure, we can clearly see that PTR and STQ are vertically opposite angles, so their measure would be equal. And we know that PTR is 45 degree, which gives the measure of angle STQ is as 45 degree. Now considering triangle STQ, we can clearly see that, or we know that the measure of angles of a triangle is 180 degree and we know the measure of angle S and angle T. So we will substitute those values to find the measure of angle SQT. So we get TSQ plus STQ plus SQT as 180 degree and we know the measure of TSQ and STQ. Substituting it, we will get SQT as 60 degree. Next sum. In figure 6.43, if PQ is perpendicular to PS, PQ is parallel to SR and SQR is 28 degree and QRT is 65 degree, then find the values of X and Y. Let's see how we will find those values. Here you can see that PQR is equals to QRT because PQ and SR or ST are parallel lines and QR is a transversal. So these two angles form alternate angles. So its measure would be equal. But PQR is equals to PQS plus SQR. So PQS is X. So X plus SQR is equals to QRT and we are given the measure of SQR and QRT. Substituting it, we will get X plus 28 degrees equals to 65 degree, which gives the value of X as 37 degree. Now let's see how we will find y. Now consider the triangle PQS. Now we know that the sum of angles of a triangle is 180 degree and we know the values of P and Q. So substituting those values we will get y. Now PQS plus QPS plus PSQ would be equals to 180 degree. Now P is 90 degree and Q is 37 degree. Substituting those values, we will get the value of PSQ, or which is equals to Y, which is equals to 53 degree. Next sum. In figure 6.44, the side QR of triangle PQR is produced to a point S. Here you can see that QR is produced to point S. If the bisectors of angle PQR and PRS meet at point T, then prove that QTR would be half of QPR. Let's see how we will prove this. Consider triangle PQR. Here you can see that PRS is an exterior angle. So its sum would be equal to the opposite two interior angles of triangle PQR, that is QPR plus PQR. So here it is PRS is equals to QPR plus PQR, or I can say that QPR would be equal to PRS minus PQR. Here I have done nothing but taken PQR on this side, which becomes negative and gives the value of QPR as PRS minus PQR. Here I did this because we have to find here QPR and we need QPR in our solution. So here we take QPR as PRS minus PQR. Next, consider triangle QRT. Here you can see that TRS would be exterior angle. So its sum would be equal to the two opposite interior angles, that is TQR and QTR. So here we can also say that or QTR would be equal to TRS minus TQR. Here I took TQR on the opposite side, so it becomes negative. So now we know, now we got the values of QPR and QTR. Now we need half. Let's see how we will. We know that QT and RT are bisectors of PQR and PRS respectively. So TRS would be half of PRS because it is bisector of here RT is bisector of PRS. So it would be half of it, and TQR would be half of PQR because it is bisector of PQR. So its measure would be half of PQR. Now we know that QTR was TRS minus TQR. Now we substitute the values of TRS and TQR in it. So we get half of PRS minus half of PQR, which is equals to half of PRS minus PQR. I took half common. Now from equation 1, we know that PRS minus PQR is equals to QPR. Substituting it here, we get QTR is equals to half of QPR. Hence, proved. Thank you, and if you have any doubt, comment in the comment section.